In the previous example, we saw how we can better our visualizations by removing extraneous elements. We can conceptualize this relationship using something called the data to ink ratio. The data to ink ratio was defined in 1983 by Edward Tufte as the ratio of the amount of ink used to describe the data to the total amount of ink in the visual. In general, the higher the data to ink ratio, the better. This means that a large amount of the ink in the visual is being used to actually describe the data, while a low data to ink ratio suggests that you are using ink that is added for other purposes rather than describing the data. These elements should be removed. Let's take a look at an example. Here, we have two graphs that are representing the same information. On the left, we have a visualization with low data to ink ratio. Notice the extra elements in the visualization that can be removed, including the blue background, the horizontal and vertical grid lines, and the outer black border. A large amount of the ink in this visualization is not used to describe the data. On the right, we see a visualization with the same data, but with a high data to ink ratio. The visual on the right only has ink used to directly relate to the understanding of the data. Comparing both visualizations, the one on the right is not only more pleasing to the eye, but it is also much easier to understand. When we're building data visualizations, we always want to strive for a high data to ink ratio. Let's go through a few more examples on how we can take a visualization with low data to ink ratio or extraneous elements and reduce it down to something that is much simpler and easier to understand. In this example, we're going to take a visualization and try to improve its data to ink ratio. Here we have a bar chart representing the number of calories for various types of foods. At first glance, we can see examples of bad visualization techniques that we've discussed previously, such as the busy background, the poor color choices, and the use of 3D gradients. Let's walk through step by step as to how we can simplify this visualization and increase its data to ink ratio. First, let's remove the wood background from the outside and this gray background from the inside, increasing contrast and legibility. We can also remove redundant labels, such as this legend from the titles. This information is encoded elsewhere. Now that we've removed the backgrounds, the heavy borders separating the various elements are no longer necessary. So let's take those out too. Remember our coloring theory. We shouldn't use more than 1 or 2 colors in a visualization unless it's encoded some value in the data. The color of these bars don't reflect any differences between the different foods. So let's remove those colors as well, except for the food of interest, in this case, bacon. Great. We've already improved the data to ink ratio quite a bit, but there's more that we can do. Recall that 3D graphs, including gradients and shadowing, can be misleading. So let's flatten out these bars and remove the drop shadows to make it more clear. We can also make the data stand out by reducing the boldness of these labels and grid lines. If we want to go even further, we can remove the lines entirely and encode the label values directly into the bars, like this. Comparing the two visualizations side by side, you can easily see the effect of improving the data to ink ratio. The visualization with a high data to ink ratio is far more clear, more interpretable, and has all the elements you need for a great visualization.